All right. I'm going to be working some of the problems that you guys asked me to do in class. So I'm going to start with number 7. Remember, these are on page AP5 in your textbook, and those AP pages are going to start right after page 356. And number 7 says, use the table above to compare the integral from 1 to 3 of f prime of x dx. Okay, so we're trying to compute this integral right here. And if you notice that this is an f prime, so f prime means they've already taken the derivative. And so an integral just means that we want to take an antiderivative. And so if we use the first fundamental theorem of calculus, it would tell us that what we want right now is capital F of x evaluated from 1 to 3. And the reason I'm only using capital F of x right here is simply because they already have f prime, and so the antiderivative of the derivative would just be the function without the prime. And now, according to the first fundamental theorem of calculus, we want f of 3 minus f of 1. And so now we've been given this chart that we're going to use up here in order to calculate this. And so we're looking for regular capital F at 3. And so those two things intersect right here with a 2. So that's 2 minus, and this function evaluated at 1 gives us the 4 right here. So 2 minus 4 makes negative 2. And so our answer choice is going to be A. Okay. Number 9 says water flows into a tank at 6 t squared plus 1 gallons per minute for time in between 0 and 2, with time measured in minutes. The tank held 32 gallons when t equals 2. How much water in gallons was in the tank when t equals 1? Now I just want to point out that this right here is an important thing that you know. The tank actually held 32 gallons when t equals 2. So what I'm going to say is I'm going to use the function g for how many gallons are in the tank with respect to t, okay? And so this is, well, we don't really know what this function is right now, but I'm just going to denote it by this. G of t is equal to, and then we really need to know a function right now because they gave us this 32 gallons when t is equal to 2. One thing I can say definitively is that g of 2 is equal to 32, okay? So g of 2, you know, when time was 2, we knew that there was exactly 32 gallons in the tank. But if you look at the function that they actually gave us up here, the function that they gave us is water flows into. So this is a rate at which water is coming into the tank. So the change in the water is equal to the function that we actually have right now. So g prime of t is equal to 6t squared plus 1. That's how many gallons of water per minute. Gallons per minute. So this is a change in gallons over change in time. That's how we know that it is a derivative when it tells us gallons per minute. That's change in gallons over change in time. Well, then that would be the derivative of g of t. And so this is what we've got right here. And now what we're really trying to find is g of 1. So we want g of 1. Okay, now this may seem complex. I have a lot of different things written up here right now. And you could have gone about this in a number of different ways. But what's important to note is that we want g of 1. So all we really need to do is find this function g of t right here. And if we find that function, we can just plug 1 in. And then when we plug in the 1, we'll get out our answer. Well, the function g of t is going to be the antiderivative of this function that we were given because the function that we were given is a rate of change, it's gallons per minute. And so what I'm going to do is take the antiderivative of this function, which means g of t, and I'm just going to use the power rule here. Okay, so this is going to end up being t cubed, and then we need to divide by 3 once we've added 1. And so this is going to be 6 divided by 3 gives us 2. Plus the antiderivative of 1 would just be t, and then we have a c, right, plus our constant of integration. And so we're really close to being able to solve this thing, except we need to know what c is. Now that is where this information that they gave you about this specific instance, right, this instant right here when t is 2, there's 32 gallons, is the critical information that we need in order to actually figure out what c is. So we know that G of 2 is equal to 32. So 32 has got to equal G of 2. So when time is 2, this thing has got to equal 32. And so a little bit of arithmetic here. 32 is equal to 2 cubed would make 8 times 2 gives us 16 plus 2 plus C. So 32 is equal to 18 plus C. And then if we subtract 18 from both sides, then we get, what is this, 14 is equal to C. And so now we can just go back to this equation that we have right here, right? And now we know that C is 14, so I'm just going to plug in for it. So G of T is equal to 2 times T cubed plus T plus 14. And so what this tells us is that, whenever this thing started, there was already 14 gallons in the tank is the way you can think about it. So, water was flowing in at this rate, but that rate would only pump in 18 gallons if you were to calculate it using a definite integral from 0 to 2. It would tell you that 18 gallons flowed into the tank from that time. And so if only 18 gallons have gone in and there are now 32 in the tank, then that means that there must have been 14 in the tank before anything even started. So, there were 14 to start with plus however much has gone into the tank. Now, what we're really concerned with in this whole problem is finding G of 1, right? We're looking for G of 1. And so that's, when t is equal to 1. And so we found this function G of t that we wanted. It's right down here. And so this is 2 times 1 cubed plus 1 plus 14. And so this is going to give us, 1 cubed is 1 times 2 is 2 plus 1 plus 14 means that there were 17 gallons after 1 second. So this looks like answer choice B. Okay, I'm going to pause it on this one to make sure the videos don't get too big and post another video.